Throughout the semester, we've talked about environmental and specifically air pollution regulations. But what I'd like to do today is talk about these much more systematically and really review some of the history of it, where we've come from, and where we're going with environmental regulations. Now, just to review, when we talk about regulations, we need to really start talking about what does this really mean in a legislative sense. Bills are what the Senate or the House introduce. They don't become a law until Congress actually acts to promulgate that act into law. And then, even then, they're still not law until the president actually signs that law into effect. On a state level, it's the state legislators that introduce bills. Those are then passed by the legislative bodies in a state and then would need to be signed into law by the governor. Now, once an act becomes a law, then the regulatory body that enforces that law actually develops rules and regulations. So, for instance, we'll talk about the Clean Air Act. Clean Air Act was passed by Congress, was signed into law by the president. We'll talk about that in a bit. And then EPA, US EPA, it was given the authority to enforce that law. So that regulatory agency, in this case the US EPA, writes regulations that explain the critical details in that legislation. Now, once those laws then are actually sent for public review or public comment, and eventually they become codified in what we call the Code of Federal Regulations. So it takes years from the time a bill is introduced to the time that that law becomes a code in the Code of Federal Regulations. Let's look at a brief history of clean air regulations. In 1955, Congress authorized the Public Health Service to coordinate the annual dispersal of $3 million for research, training, and technical assistance regarding air pollution. This law was extended in 1959 when Congress increased the funding to $5 million. It was then expanded in 1962 when Congress then dedicated $5 million per year. And at this point, the first set of automobile emissions became regulations became part of the Public Health Service program. Now, there were a number of events that actually led to the Clean Air Act in 1963. We've talked about some of these. These include the series of smog events in London, air pollution episodes in the US, including Donora, Pennsylvania, Birmingham, Alabama, Los Angeles, St. Louis, Missouri, New York City, Kingston, New York. There was also a second national conference on air pollution that was sponsored by the Public Health Service. And so in 1963, Congress passed the first Clean Air Act. This gave the Public Health Service authority over enforcement. It directed the Department of Health, Education, and Welfare to prepare criteria documents about the effects of air pollution and human health. There was still no enforceable regulations, though. It required semi-annual reports to Congress on automobile emissions. It established a technical committee, and it authorized $65 million towards these efforts. In 1965, Congress passed the Motor Vehicle Control Act, and this set emission standards for 1965 vehicles. It also required research, understand the effects of these emissions. It called for research also on SO2 emissions, and it called for provisions to control air pollution between the US, Canada, and Mexico. So start to recognize these transboundary issues regarding air pollution. 1966, Clean Air Act amendments were passed, and then in 1967, the Air Quality Act was passed, which established air quality criteria, recommended air pollution control equipment. It authorized the states to develop and adopt their own standards, as well as implementation plans to achieve those standards. And it provided financial aid for motor vehicle inspections. Now, in 1970, the Environmental Protection Agency was created. It's actually created by Richard Nixon. And the EPA then, under the Clean Air Act amendments, was given the power to take action to fight environmental pollution. The Act was expanded from the original set of guidelines in which states regulated the sources of air pollution to the establishment of a national regulatory program. So this was the first time that a national program was set up. In this case, then there were specific air quality requirements, federal enforcement, and federally issued permits, which required large industrial entities to address and control air emissions. This is a major change from a local and state level to a federal level of enforcement. The Clean Air Act set 5 criteria pollutants. These pollutants were carbon monoxide, nitrogen dioxide, sulfur dioxide, suspended particulate matter, this was actually known as total suspended particulates, or TSP, and photochemical oxidants. As we've talked about before, it's also set health-based ambient air quality primary standards and secondary standards to prevent environmental and property damage. Now in 1990, the Clean Air Act was amended. In this case, carbon monoxide, nitrogen dioxide, sulfur dioxide remained on the list of criteria pollutants. Instead of TSP, particulate matter was then addressed as PM2.5, that is particulate matter less than 2.5 microns, and PM10, that is particulate matter less than 10 microns. Ozone was then added instead of photochemical oxidants. Lead was actually added in 1978. It was amended here to reduce the levels by an order of magnitude to 0.15 micrograms per cubic meter. The Clean Air Act amendments gave the U.S. EPA the authority to designate attainment and non-attainment areas. A geographical area that meets or exceeds the primary standard is known as an attainment area. Within the attainment area, industry is required to use the best available control technology. Federal regulations require a cost-benefit analysis as part of the permitting process. In the cost-benefit analysis, the industry must evaluate the environmental and health impact of the proposed change versus the cost of treatment. Best available technologies are used for mid-range pollution control. It is more restrictive than reasonably available control technology and less stringent than the lowest achievable control technology. When applying for a permit, the industry must look at the total source emissions, the regional environmental impact. They must evaluate several control technologies and look at a reduction in emissions, the energy consumption by this technology, and the cost of the technology. And then they rank technologies, evaluate the most effective control technologies, document this, and then they select the best available control technology. And then that information is documented and sent to the state agency for review and ultimate approval. As mentioned in the previous slide, in assessing the best available control technology, the industry must go through the process described. An example would be for dry bulk fertilizer handling. So for example, there are multiple technologies that could be used to control emissions. We'll talk much about these later, but for example, these could be a baghouse or what is referred to as choke feeding. It could be an enclosed conveyor for mechanical transfers. It could be using an enclosure for mixing. Again, what the industry would need to do is to evaluate the total source emissions, evaluate how these control technologies would reduce emissions, how much energy each would consume, what is the cost of each technology. Based on this, they would rank these three technologies, determine which would be the most effective, document that, and then send that document to the state agency. An area that does not meet the primary standard is referred to as a non-attainment area. Approximately 123 million Americans live in an area that is non-attainment for at least one NAAQT, or National Ambient Air Quality Standard. Most difficult to meet is the ozone standard. That's the 8-hour ozone standard. It's the most commonly occurring pollutant, which is non-attainment. And as we've discussed before, ozone is a secondary pollutant. It's much more difficult to control secondary pollutants than it is to control a primary pollutant. You also see the same is true for PM 2.5 and PM 2.10. PM 10 tends to be predominantly a primary pollutant, PM 2.5 a secondary pollutant. It's more difficult to control that secondary pollutant. We've done a very good job with controlling SO2. However, with lead, despite the fact that lead has been banned for use in household paint, for use in gasoline, and for use in most aviation fuels, for decades now, there are still thousands of areas that are non-attainment for lead. For non-attainment areas, the lowest achievable emission rate technologies are required for new or modified sources. On the other hand, reasonably available control technologies are required for existing sources. Remember, the lowest achievable emission rate technology is more stringent than the best available technology, whereas the reasonably available control technology is less stringent than the best available control technology. The analysis that one goes through is similar to what was previously described for attainment areas. This map shows the 8-hour ozone non-attainment areas. This is based on the 2015 standard. We talked about this when we talked about ozone smog, and you see, for instance, that there are a number of counties in Michigan that are non-attainment for ozone. We'll talk a little bit later about what this means in terms of how the state or the counties need to make decisions and what implement processes or procedures or policies that will allow them to come into attainment. Again, here is again a list of, or a map showing the attainment. This actually shows counties that are non-attainment for multiple national ambient air quality standards. So you see the most are non-attainment for only one. So you can see if most of the counties in Michigan are non-attainment for only one pollutant. On the other hand, there are a few that are non-attainment for up to all 6 national ambient air quality pollutants. The State Implementation Plan defines the combination of local, state, and federal actions and emission controls needed for an area to meet the ambient air quality standards, and for an area that has attained these standards to maintain compliance and prevent what is known as significant deterioration, or PSD, of air quality. The first step in developing a SIP is to divide the state into geographical regions known as air quality control regions. An air quality control region could be a metropolitan area or a county. Using these areas for management purposes, the state could devise their own requirements for controlling air pollution related to specific local needs. This could include the control of new and existing sources of pollution. An example of a common measure taken by states within the SIPs is the requirement that all motor vehicles be regularly inspected and tested for air emission control. The SIP is developed by state and local officials but must be approved by the US EPA. Once approved, it becomes legally enforceable on both the state and federal levels. If all or part of a SIP is not approved, EPA assumes responsibility for developing an appropriate plan. To supplement the SIPs, federal regulatory and support programs are in place. One support program, EPA establishes control techniques guidelines for controlling air pollutants for specific industries. These guidelines provide the states with information on existing control technologies referred to as reasonably available control technologies, which we've previously discussed. As mentioned previously, prevention of significant deterioration is used for areas in which the National Ambient Air Quality Standards, the NAAQS, are in compliance and it's used to prevent deterioration of air quality. It is a formal technical procedure. It is the responsibility of industry seeking an operating permit to show that any changes in air quality are consistent and allowable within the classifications, which I'll mention in the next slide. You want the permit to be as general as possible so as to take into account any plausible or possible operational changes. The process called new source review is required whether a major source or modification is planned for an area where the NAAQS are exceeded, so in a non-attainment area. Permits in non-attainment areas must meet the lowest achievable emission rate. New source review permits are source-specific, which gives the state the authority to require more stringent controls to meet the ambient air quality standards in a specific geographical area. In order to prevent industry from relocating to avoid regulations, areas are divided into 3 classes. Areas with pristine environmental quality include national parks, wilderness areas. Class 2 areas are regions where industrial development is allowed, provided that changes in air quality are within the prescribed areas. These include all attainment areas and non-classified areas. Class 3 areas are current industrial regions where further development is allowed, provided that the NAAQS are not exceeded. These are areas selected by states and are designated for development. New source performance standards are federal standards promulgated for major and minor sources on a category-by-category basis. New source performance standards are national emission standards that are progressively tightened over time to achieve a steady rate of air quality improvement without unreasonable economic disruption. The new source performance standards impose uniform requirements on new and modified sources throughout the nation. These standards are based on the best demonstrated technology, which refers to the best system of continuous emission reductions that has been demonstrated to work for a given industry, considering economic costs and other factors, such as energy use. In other words, any new source of air pollution must install the best control system currently in use within that industry. The format of the standard can vary from source to source. It could be a numerical emission limit, a design standard, an equipment standard, or a work practice standard. Primary enforcement responsibility of the new source performance standard rests with the EPA, but this authority can be delegated to the states. States can adopt an new source performance standard or impose limitations of their own, as long as the state requirements are at least as stringent as the federal requirements. The states have to be certain that any new source will not adversely affect their SIP. For this reason, all new sources must undergo a review process known as the new source review. New source review is required for all new stationary sources of air pollution and major modifications to stationary sources. It is required for both attainment and non-attainment areas. The Clean Air Act amendments of 1970 required EPA to identify and list all air pollutants that may reasonably be anticipated to result in an increase in mortality or an increase in serious, irreversible, or incapacitating reversible illness. This was in addition to the already identified National Ambient Air Quality Standard pollutants. For each pollutant identified, EPA was then to promulgate national emission standards for hazardous air pollutants, known as NESHAPs, at levels that would ensure the protection of public health with an ample margin of safety and to prevent any significant and adverse environmental effects, which may be reasonably be anticipated on wildlife, aquatic life, or other natural resources. The approach used by EPA to promulgate NESHAPs was based primarily on health considerations. In other words, EPA has to establish a numerical limit that would protect human health from any adverse effects. The agency found it very difficult to establish these standards because of the uncertainty in assessing health risk. In the 20 years following the enactment of the 1970 legislation, EPA identified only 8 pollutants as HAPs and regulated the sources of 7 of them, listed here. The passage of the 1990 amendments renewed the emphasis on controlling emissions of hazardous air pollutants on the federal level, but it changed the approach to regulating HAPs based on available control technology. A list of 189 compounds was provided to Congress to be controlled as HAPs. Since then, 2 compounds were removed from the list so that the current list includes 187 compounds. As mentioned, there are now 187 HAPs that are regulated, and this map shows an estimated county-level cancer risk based on the National Air Toxic Assessment. There are 30 urban air toxins that are believed to pose the greatest potential health risk to populations living in these urban areas. So let's look at what have we achieved with the Clean Air Act and the previous air regulation. As you can see from this figure here, the concentration of carbon monoxide in the air has significantly decreased in the period of time since 1980 to 2019. This is in part because of improved or more stringent regulations regarding carbon monoxide emissions from vehicles. However, many cars actually emit more pollution than is determined by the testing that is done in federal test procedures, and that's because of improper maintenance, tampering with control devices, etc. There's also a greater use of light trucks, and those emission standards are less stringent than that for passenger cars. We've also seen an increase in the number of vehicles on the road. We've also seen about a 3% per year increase in the miles traveled per vehicle. And there's been no significant change in the total emissions from fuel combustion and industrial sources. The NOx budget trading program, which we discussed when we talked about acid rain, was a market-based cap-and-trade program created to reduce the regional transport of emissions of nitrous oxides, NOx, from power plants and other large combustion sources that contribute to ozone non-attainment in the eastern United States. NOx is a major precursor to the formation of ground-level ozone, as we discussed. The NOx budget trading program, which was designed to reduce NOx emissions during the warm summer months, referred to as ozone season, when ground-level ozone concentrations are the highest. The NOx budget trading program was established through the NOx State Implementation Plan call promulgated in 1998. All 20 affected states and the District of Columbia chose to meet mandatory NOx SIP call reductions primarily through participation in this program. From the beginning of the program implementation in 2003 to 2008, the program dramatically reduced NOx emissions from power plants to improve ozone air quality in the eastern United States. In 2009, the program was replaced by the Clean Air Interstate Rule, which was later replaced by the Cross-State Air Pollution Rule in 2011. As you can see here, about a 62% decrease in the national average in NOx was achieved. You'll see that this is not as great as what was achieved with carbon monoxide, nor is it as great as what was achieved with SO2. Now shown here are the reductions in the SO2 emissions. This is predominantly due to reductions in the use of high sulfur coal, reduced use of coal itself and replacing it with natural gas. And this has resulted in a very significant reduction of about 92%. The earlier reductions were because of the acid rain program, and the later reductions are really the result of decreased use in coal and also natural gas. As you can see here, only about 35% decrease in the national average for ozone has been achieved. And in many cases, we're still, as you've seen with non-attainment maps, we have still, in many cases, in non-attainment for ozone. Ozone has been our biggest challenge. As I've mentioned, it's a secondary air pollutant. It's much more difficult to control than is a primary pollutant like SO2. Like ozone, PM2.5 is a secondary pollutant. And as you can see here, there's only been about a 43% decrease in PM2.5 in the last roughly 20 years. Like ozone, it's difficult to remove, and we still have a significant amount of work left to do to further reduce PM2.5. Now the lead air quality is significantly improved. What you see here is that since 1980, there was a 98% decrease in the national average. What did we do? We banned leaded gasoline, we banned the use of leaded paint, and this has had dramatic effects on improving the air quality and also reducing the blood lead levels in children. As you can see here, back in 1976 to 1980, the median blood lead level in children was about 15 micrograms per deciliter. It's now less than 1 and continuing to decrease. Lead is important. It's a neurotoxin. It affects neurological development, especially in small children. So this has been a wonderful improvement and very successful improvement in air quality. Now, in many cases, we hear that we can't have strong environmental regulations because of the impact on the economy. And what you see here is that since 1980, we've had roughly a 71% decrease in aggregate emissions. That's of the 6 criteria pollutants. On the other hand, we've had a 182% increase in our gross domestic product, 114% increase in the miles traveled by vehicles, along with a 44% increase in population and a 28% increase in energy consumption. So all of these have increased, yet at the same time, we have been able to make significant improvements in air quality. The one pollutant that we're still addressing is CO2 emissions. You can see that there's been roughly a 15% increase since 1980, although if you look since 2008, as we've discussed elsewhere, there has been a significant decrease in CO2 emissions, and as we talked about, due to changes from coal to natural gas and the increase in the heat content of natural gases compared to coal. The recession in 2008 did have a significant impact on emissions. And then lastly, as we're moving to renewables, you see a decrease in CO2 emissions. So what have we learned? We've learned that the greatest reductions in air pollutants were observed where the emissions were the highest. The lower we go, the harder it is to remove or to reduce the concentration of these pollutants. We also learned it's much easier to control primary pollutants than it is to control secondary pollutants. Cap and trade policies protect the environment and human health, and they work. And also, we've learned that transparency and accountability are necessary and are part of protecting public health and the environment. So from this lecture, you should be able to describe the basic content and history of the Federal Clean Air Act. You should be able to define such as the acronyms listed here, and also explain the differences between attainment and non-attainment areas. And you should be able to describe the impact of regulations on air quality. I hope this was helpful and look forward to answering any questions you may have. Just feel free to email me with your questions.